Good evening all, hope you are all well. So today we are going to discuss the third problem in the Codeforces Round 973, Div 2. The problem name is password cracking. So let's get started. Let's start by reading the problem statement first. Dimansh learned that Mansoor wrote something very unpleasant about him to a friend, so he decided to find out his password at all costs and discover what exactly he wrote. Believing in the strength of his password, Mansoor stated that his password is a binary string of length n. He is also ready to answer Dimansh's question of the following type. Dimansh says a binary string t, and Mansoor replies whether it is true that t is a substring of his password or not. Help Dimansh find out the password in no more than 2n operations, otherwise Mansoor will understand the trick and stop communicating with him. We'll have at most 100 edge cases. So this is an interactive problem. So you'll have to print a question mark and the string for the input, and for the output you'll have to give a exclamation mark and the final string. After giving the input for this, we will get a cin for C++. Like what would be the output? Like if this string is included in the final substring or not. So if it's included, then we'll get a 1, otherwise we'll get a no. So in the response to this query, you will receive 1 if the t is a substring of yes, or 0 otherwise. So now let's understand the problem. Let's suppose we are given a string. Like suppose this is my password string that Mansoor has. What we do is we give it a string. Like let's suppose I give 100. I will give this substring and ask if this is a part of this string or not. So for this it will return a 1. Let's suppose I give 111. So this is not a part of this string as a substring. So we'll receive a 0 here, right? So by asking these queries, like we can only ask till 2n times. N is the size of the string. So for a string of size 5, we can have at most 10 queries. So in 10 queries, we need to answer what is this string in at most 10 queries for a string of length 5. So what comes to our mind? Like, so if we didn't have this constraint, like let's suppose we didn't have to answer in 2n constraints, then we would just try all the combinations. Like the combination would be 2 power n. Like we'll try all the combination. Let's suppose this is a combination, this is another combination, this is another combination. So we will try all these combinations, and for any one it would give a yes. So that would be our answer. But we cannot do this. Like we only have 2 into n queries, right? So what we can do? Let's try to build the string. Like we have the string initially. We would, let's say, start with a 0 or a 1. Let's say we start with a 0. We will ask if this 0 is a substring of this or not. If 0 is not a substring, then we will have a 1, right? And after each one, we will try and add 0 or 1, right? Let's suppose we have a 0 in the start. Let's suppose we pass 0 as a query. So we will find a yes for this. Now again we append a 0 for this and ask again. Now 0, 0 is also a substring. So then again we add a 0. Now we get a no for this. Why? Because 000 is not a substring in this. So then we would cancel this 0 and we would instead place a 1 here. Now 001 is a substring. So we will get a yes again. Now we will again put on a 0. So this is also a substring for this. So again we will get a yes. Then again we would try to put on a 0. Now this is not a substring. So we will get a no here, or a 0 here, 1 here, 1 here, and 0 here. So now we'll try for a 1, and this is also a no. So now we have exhausted the moves. Like even if we put in more elements in the front, we won't be able to get this string. So what we can do is, if we cannot get a string, like even after placing a 0 and a 1, like after we place a 0, we should get a yes. If that's not the case, then for a 1 we should get a yes. Like there are only two combinations, 0 or 1. If for both the combinations we get a no answer, then that means we have a suffix for our string, right? So we would go in this direction. So like initially we have a string this. Let's suppose we had this string. So we were initially finding in this direction. Like we found this string. Now we need to find this part of the string as well, right? So we would take this string and we would append it. Like we'll append a 0 here first. Now this is not a substring. Then we will append a 1. Now this and this would give a yes. Once that gives a yes, that means we have an answer, and we will print the answer. So as a result of this, we can get a we can exceed our 2n limit. So there's one edge case in this. Like, let's suppose we get a no here. Then if we check for this again, in this case we can cross the limit for 2n. If you count these, let's suppose, let me get it again, 1 0 0 1 0. For a 0 we'll get a yes, for 0 0 we'll get a yes, for 0 0 1 we'll get again a yes, 0 0 1 0 will again get a yes. In this 0 0 0 was a no. Right, now again we try 0 0 1 and with a 0 here, so we'll get a no here, 0 0 1 0 1 and a no again. So after this we would try appending it in the front. So we'll append a 0 0 1 0 and a 0 here, so we'll get a no here and 1 0 0 1 0 and we'll get a yes here. So in total we used 1 2 3 4 5 6 7 8 and 9 queries, and in this we had almost all the queries. So like, we can exceed the limit. From this we can know that we can exceed the limit. So in the last test case, like when we are appending in the previous direction, if for the last test case we know that it's not a 0, so that's for sure that this element would be 1 then. So in that case we can reduce this query. Like this we don't need to check that. After we get a no for this, we know that it would be 1. That cannot be a 0 now, since for 0 the answer is no. And this suffix is already there. It has to be a 1. So we are sure about it. So we just need to do the same in our code. So let's write the code here. We'll have an input, that is n, that is the length of the string. We would have a password string that is initially empty. We'll have a I index. We would iterate from 0 to n. If like we have a current, if password plus 0, if this is our current, if this is valid, we will add it. We'll add the password plus is equal to 0. Like we'll add a 0 in the end. Otherwise, we'll check for 1. Like we'll assign current to password plus 1, and we'll check. If this checks also fail, then we will break this loop. That means we have got a suffix. Like we have got this. Now we need to find the prefix from the prefix. So now we'll again have from I till 0 till whatever the I is till n. Now we'll have current as 0 plus password. Now if this is valid, then we'll just add. Otherwise, we'll have current as 1 plus password. And we don't need to check this. Like if this is false, this is going to be true. We don't need to check this. So we can save some queries here. So I think this would work. And while during the contest, I didn't recognize this. Like I use the same code for this and this here. So I think it would reduce the queries. Like we can simply have, like if 0 doesn't work, then it is going to be a 1. So here we'll have at most n queries. Like whatever is the remaining length, we'll have n, and for here we can have 2n queries. Like for each one we'll be checking. Like we'll have check twice for this after appending a 0 and after appending a 1. But here we'll only check once. Like if it's a 0, then it's a 0, otherwise it's a 1. Let's code it up now. So we have our boilerplate code here. We'll be given an n, that is the size of our string. We will have a string password that is initially 0, that is initially empty. We'll have an I variable that is for iterating. We will make this, we'll widen the scope for this. Now if the current, let's first append a 0 at the back. Now we will print question mark and the current and a new line. Let's have a response also here, and we will have a response. If this response is 1, that means this is the current string is a substring of the final string. Then in the password, we will just add the pushback 0. Otherwise, we need to check with 1. I'll just copy this again. This would be a corrector. Current, and we'll have a 1 here. Now if this result is 1, then we would push back a 1. Otherwise we will break. That means we got the suffix now. And after that we need to check the prefix. So we will have an I, and I less than n, and I plus plus. I'll just copy this whole code again for the second while loop, for the second for loop. I'll paste this. So instead of the back, we'll start with the front. So if this is possible, then we can't push back here now. We'll have to assign it again to 0 plus password. Now we'll have to check with a 1, and that we know it is a 1. So simply we can, instead of doing this, we can simply do this now. We'll surely know that it is a 1 or it is a 0. And in the end, we would just print our password. Let us now try to run it. Minus std. Let's say I have one test case and the length of the string is 4. Let's say I have my string as 10 and 10. So initially it is asking if 0 is a substring or not. So yes, 0 is a substring. So we will give it 1. Now it is asking 0 0. Now 0 0 is not a substring. So we will give it a 0. Now it is asking 0 1. 0 1 is a substring. So we will give it 1. 0 1 0 is also a substring. So we'll give it again 1. 0 1 0 0. This is not a substring for this. So we'll give it 0. 0 1 0 1 is not a substring. We'll again give 0. Now it went on the front. So 0 0 1 0. That is also not a substring. We'll give it 0. So in the end it gave us 1010. That was our initial string. So let's see the number of operations. 1 2 3 4 5 6 7. So it took 7 operations only. So this code will work. So this code works. Now let's try to submit it. Now let's submit the code. It gave us a wrong answer on the second test case. The result is 1. Then we need to add a 0 here. Okay. So let's try to submit it again. And it got accepted. That means our approach was correct. I hope you understood the problem. Comment down what was your approach for solving the same problem. The solution link would be in the description section. Do check it out. Like the video, subscribe to the channel and share it with your friends. Thank you.